Hello guys, my name is Noah Geiger, and this is the last lab, Lab 5, and I'm going to be doing the dropping a Slinky video. I'm going to start off by going to our tracker app. In the video, there's this kind of older dude, and he has a Slinky, and he drops it, and we're going to see what happens when he drops it. Boom. And you kind of see right here, the Slinky stays stationary, or the bottom of the Slinky stays stationary above the ground, almost hovering for about a second or two, and then it just collapses to the ground. So we're going to be investigating why it stays up like that. You can see we use tracker to mark all our points. It kind of looks a little bit of a nice curve, little choppy, probably just because of the camera angle. And I notice the frames per second are pretty bad, so that's probably to do with it. Concepts we're going to just keep it simple. We're going to use Newton's second law, we're going to use drag, and we're going to use the point update formula. We're gonna go down to Python, or glow script, I should say. And I wrote this glow script here, and you can see it accounts for the two forces acting on the Slinky. And that's gonna be gravity and tension. So you see we accounted for that here, we accounted for that here. And we're gonna run it, and we're gonna see what it gives us here. And there you go. You can see it is constant, 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 constant. Then it constantly decreases to the distance. Um, This can be explained from seconds 0 to about 5.5. The reason why it is constant and not moving is because the force of gravity cancels out with the force of tension. So force of tension is going to try to be pulling up. The force of gravity is going to be pulling down. So that bottom of the Slinky is going to remain unchanged until the top of the Slinky, which is about that 5.5 mark, hits the bottom, and then it'll cruise down. And this line is linear and not really a curve just because it's such a short distance. So acceleration isn't really doing much there in terms of like the whole thing. So we're going to go here. So why? Because the bottom of the Slinky stays stationary due to the tension force and the gravity force being equal to each other. After no tension force is present, the Slinky falls on the ground. Um, yeah. So thank you guys. Hope you had a great year, and hopefully see you guys next year.